Thank you very much. Can you hear me? Okay, I will try to give an overview of our work and some examples that hopefully will be useful. Our group in Berlin, and also the same group that works in Hamburg, dedicates most of its works to the writing materials. And in these writing materials, we're mostly working on soft substrates, means on the papyrus, parchment, leather, and recently we started also working on paper. Now, of course, inks is very important in all this, and we will maybe start with the inks. And one of the interesting things we want to know and we are trying to reconstruct is the history of the inks, how inks changed in time and place, and what inks appeared when. And we hope that our grandchildren will be able to reconstruct and make the database of the ink and then date and localize the manuscripts according to the material composition. And you can see that this timeline of the inks is not yet built. We're always working and trying to contribute to find new recipes, to make analysis of different manuscripts and to fill the gaps. Now, in the antiquity, everybody was writing with carbon ink, but already in the late antiquity, something like similar to iron gall ink, or at least something appears that reminded iron gall ink. Additionally, there were carbon inks with other metals, with copper, and we would like to know when, where, and who was using these inks. Now, when we go to Europe, we know that there were also plant inks that were used extensively. Greeks were using plant inks. Also, some plant inks were used in the Northern Europe. And at the same time, starting about 3rd, 4th century AD, iron gall ink found its way into the manuscripts. However, the first recipe of this ink appears only in the 12th century, though by 12th century, iron gall inks were all over. So in our work, we are studying manuscripts from different cultures and different times, and we are recording the composition of the inks, and we're trying to see how the exchange of inks went. The history of parchment is even more difficult to reconstruct than the history of inks, because it's more difficult to study non-destructively. Now, again, everybody started with writing on leather. At a certain point, parchment appeared somewhere, and I believe it appeared at the same time in the east, around Babylonian, or in the west, in Greece. In the cross-section of Babylonian and the west, in Palestine, we find actually both types, and parchment of antiquity was halfway. There was some kind of a hybrid between leather and parchment, because it was parchments that were tanned, which are neither parchment nor leather. Also, in the late antiquity and the early Middle Ages, we have seen such phenomenon as split parchment. And this split parchment happened because in the antiquity, the production of parchment did not involve putting the skin into a lime solution, calcium hydroxide solution that removes all the fat from the skin. So when the fat was still in the skin, it was possible to separate skin in two different skins going along the fat layer. And very thin parchments from late antiquity are known, as well as the early medieval parchments. At certain time, somewhere in the history, and we still do not know exactly where and when it happened, people started to remove hair from the skins using lime solutions. And after that, the splitting, just simple splitting along the fat layer, was lost, and again the splitting of parchment came later when it was possible to split mechanically. So we're trying to reconstruct who and how, who was using what kind of parchment in the late antiquity and early medieval ages. Now, since everybody is using C14, I just wanted to remind everybody that one of the most difficult things in C14 dating is a contamination. What happens when the organic matter that is dated is contaminated can be seen here. If you have parchment that has addition of the so-called old carbon, or if conservation materials involved old carbon, you would have completely different age. So one of the other important things that we pursue as a material science group is to try to make an analysis and to see whether the pieces to be dated are contaminated or not, to try to help those labs to clean the organic matter better. Now, let's have a look at the techniques. I will not present the whole toolbox because it will take very long. I will present a couple of methods that are used by many people and try to say a couple of words about their principles. So, of course, we all use imaging techniques, and one of the very useful imaging technique is reflectography. We are using reflectography to identify the type of the inks. You see here 3 different types of inks. In the upper row, it is plant ink extensively used in the early Middle Ages. If you illuminate your manuscript first with visible light, and you see here, this was good. I'm sorry, I have to find, okay, the upper row, plant inks, you see it invisible, it completely disappears in infrared light. Iron gall ink do not disappear, do not necessarily disappear completely, however, they significantly change their opacity. They become more transparent or change their color. Whereas carbon ink are not influenced by the illumination. You can see them exactly in the same way in both lights. We use this method to quickly identify the type of the ink. Another possibility of imaging is based on X-ray fluorescence, and I will speak a little bit later about this, but here we were interested in this area that was covered, and we use this device to make this area visible in one element. This is another type of imaging that is used now extensively in paintings, just to identify different pigments, but we are using it also in manuscripts to identify the inks. X-ray fluorescence. It is a method that everybody uses, and it is based on the fact that you can eject one inner shell electron, produce a hole, then the inner shell will be filled, and the fluorescence is released, which we can detect and write like a spectrum. And in this spectrum, every line corresponds to an element, and the intensity of this element is roughly proportional to the existence of the element. So it's not exactly proportional, but we can calculate the amount of the elements from this spectra. And here you can see that we have 2 spectra, one in the red and one in the black. One is parchment, and when you see that iron appears in parchment, however, in this ink, you have a much higher amount of iron. This is another method that everybody uses, and I think Patricia will speak about it after me more intensely, right? Okay, so I can leave it at this now. Another method we're using extensively, it is chemical analysis. And chemical analysis is based, we identify with this compounds. And it is based on the fact that atoms in molecules are bound with each other, similarly like balls are bound with a string. And we can measure this force with which they are bound, and then we can identify the compounds. And again, we have it in the form of spectrum. And here you have two spectra of the same compound. The upper one is infrared spectra, and what I show here is two polymorphs of calcium carbonate, calcite, and aragonite, and they are different in the spectra. These polymorphs are very important for provenance of the manuscript. So we usually try to make this analysis to see which of those polymorphs is present. And in the Raman spectra, in this case, we do not almost see the difference, but in other cases, it is other way around. Big difference in Raman and no difference in infrared. With all this introduction, this was a short introduction to give some examples. And when we were thinking about what examples to show you, we decided to take as an example the fragments that are being used in bibliotheca coranica, no, how it's called? How the project is called? Coranica, just coranica. The samples were given to us by Michael Marx and Tobias. And
Samples were taken by Christian Robin in Yemen.
First, this is one part. We had a number of different samples. So these samples were taken by Christian Robin in Yemen. There were 6 samples and we got. I just give you the picture of one which is representative. They are very similar. Then we have another 7 samples, 5 samples from Chester Beatty Library. If you need to know which manuscript it is, Michael and Tobias are here, so they will give I didn't get it. And a completely different type of parchment from Munich. Let us first look at the ink. If you look at this picture, and this is reflectography picture, so here you have it invisible, you have the ink invisible, then you have ink in the infrared, and you would say it is carbon ink because you don't see difference. However, if you look now at the distribution of the elements in those inks, and this is the area of the ink, and this is the area of the parchment, you will see that not only iron appears enhanced in this area, but also other elements such as manganese, zinc, and copper. Those elements, when they appear together with iron, indicate that in the basic recipe vitriol was used, and vitriol was a common ingredient of the iron gold inks. So in this very case, we would say this is not carbon ink, but this is not iron gold ink, but this is a mixed ink. And one of the things that we know, and in this case, and what we usually know about the inks from in Arabic manuscripts, that a great number of mixed inks was used, which is very important. Now, if we go over to other inks, you can see again that you have carbon ink. Here you have iron, however, no satellites that would indicate the vitriol, but you have also common iron gold inks, and you see reflectographic changes. Now my time is almost gone, so I will take a couple of minutes to speak about parchment. Now, studies of the ink are very well known, and we can not only identify the inks, we can also compare inks, and this is a kind of a topics for a long lecture. However, one of the things we do with the inks, we identify their composition and we compare them. Now, what do we do with parchment? As I was saying in the beginning, parchment, what kind of parchment we're using? This parchment is very light colored, However, in this spectrum that we see here, there is no calcite. So we would say this parchment probably was not done with the use of lime. However, it was probably done with the help of starch, which would be unusual had we not known that starch was even used in Coptic documents around 10th century. However, here, calcite was always used. Now, if we look at compare other fragments, and this is fragments from Chester Beatty Library, they were white parchments. They still have no calcite, and they have starch. We compare them to the other fragments from the Munich library. They have absolutely different type of a composition. And this composition contains alum, which we also know from antiquity. If we look at the composition of this parchment, we find that there is some calcium involved, but calcium can be present in the parchment because it is skin and it is natural to have a little calcium. When we go, however, to parchment from Sana'a, we find with astonishment that we do not even see anything but calcium. We see only calcite, a massive presence of calcite and a little bit of starch still there. And when we look at the contents of calcium, we realize that it is immense, it's huge. So, our question now, if the parchment of Sana'a was prepared with the help of the lime, or it is possible that if this was a palimpsest, then calcium carbonate was used for the secondary preparation, which we'll know from the work on the palimpsest. Now, to answer this question, I would need to make destructive analysis. Since we are not allowed usually to make destructive analysis, we have just started a very important project which would deliver us a tool that would allow us to look into the parchment without destroying it. Oops, and we are now working on this. And with this, thank you very much.